night, everyone. I think the flyer was a bit misleading. I told Shiva to put artificial intelligence in competitive chess as the title, but it's really just covering artificial intelligence in chess. As these engines, it's basically available for most people to use. Um, so in game theory, really, artificial intelligence is a large part of it. AI developers test most of their new innovative artificial intelligence techniques on video games before they try it in more important fields. They do this because any game consists of patterns, and to become better at any game, you have to be able to identify any pattern that leads to winning positions or leads to you winning whatever, completing the objective in the game. And of course, for any machine learning technique or AI, the primary function is to identify patterns in data. So AI has a long history in chess. The first recorded chess game dates back to the 15th century, but the first automated chess player was developed by Alan Turing, a guy all of you know, father of modern computing in 1950. Um, chess engines improved in strength as new AI techniques were developed and more resources were available as the amount of RAM provided to computers improved. And in 1997, a company called DeepMind came up with a chess engine called Deep Blue, and this was the first, and their engine, they tested it against the world champion at that time, Garry Kasparov, and the chess engine won, and this was the first time that the chess engine defeated the world chess champion. Before that, chess engines weren't really that strong. Up until the 80s, they could only beat like beginners. And then as, of course, resources improved, the engines improved, and 1997 was a landmark as chess engines surpassed human strength in the game of chess. Why use AI in chess? Well, from the image here, you can see on the screen, the first move in a chess game for the white pieces, you have 18 possible moves. The 8 pawns can move either 1 square or 2 squares forward, and the knights can make 1 move out. And black has 18 replies to this move. So immediately in the second move, you have 324 possible positions and 18 possible moves on either side. And as the game opens up and more pieces they can get to more squares, the number of possible moves in a given chess position usually increases by a factor of 40. And the number of different positions possible in a chess game increases exponentially. Modern AI can quickly determine the best move from millions of positions and also identify the best positions. In modern times, probably since the 2010s, in the 2010s, modern chess relies on AI. The current world champion, Magnus Carlsen, he analyzes games that chess engines play, and he has adopted some of the moves or the style that the chess engines use into his game at the very highest level. But at a lower level, to people now beginning to play chess. Chess engines are used to provide feedback on games that you played. So if you play games on like chess.com or on Lichess, they have chess engines available on their website to help provide feedback on the game you played against someone else. They evaluate each individual move so they can tell you like which move you went wrong in your game. You know, if you played one bad move or if it was like a sequence of bad moves. And chess engine, and that's at the lower level. At the higher level, chess engines have disproved opening theories that have been around for centuries. If you know opening, the French opening has been around for a very long time, and it was disproved by one of the engines I'm going to talk about in this presentation. And so there are two really popular chess engines. A few have come about recently. One known as Leela, that's a chess engine that came about recently. But the two most popular ones are AlphaZero and Stockfish. Stockfish is the engine used by Lichess on their website to evaluate games. So in 2017, they played a famous match against each other, consisting of 100 games, and AlphaZero destroyed Stockfish. AlphaZero won 72 games and 28 were drawn, which was a resounding victory given at the time in 2017. Before this game, the 2017 Chess Engine Championship was played, and Stockfish won that tournament. And then AlphaZero came in December in 2017 and destroyed it. AlphaZero has changed the way chess engines were developed. Stockfish followed a more traditional way in developing chess engines, which was to model more of how humans play chess. So Stockfish could provide the best human moves, no blunders. You can get good positions if you follow the moves Stockfish provide, but AlphaZero provide a different style, a different way of playing chess, which was beyond like what humans could understand. So the difference between these chess engines, this is only a simple difference, but it's also very important. AlphaZero is was developed by the same company, DeepMind, that developed Deep Blue back in 1997. But Google bought out DeepMind, and they have poured money into developing AlphaZero. So the code for AlphaZero is very private. It's one of their proudest developments in Google. But Stockfish is actually an open source engine. If you go on Stockfish's website, you can download the latest version of Stockfish and run it on your computer back home. They're also developed in very different ways, but more on that later. So the main talking point of this presentation is AlphaZero, because AlphaZero, it came in 2017 and destroyed Stockfish in a competition which was unheard of. Stockfish was the baseline. It was the best engine at that time until AlphaZero came and defeated it. So up to this point, chess engines utilized a database of chess openings and endgames. So they would play known theory for chess openings, and in endgames when there are only like a few pieces, if it knows the way to win or the move that you have to play to win, it would simply go in the database, pull those moves, and play from the database, play moves from the database. But AlphaZero uses reinforcement learning. So when AlphaZero begins training, it has never played a game of chess before. It is only given the rules of chess as background knowledge. It does not know anything else. And initially in the first few games AlphaZero plays against itself while it's training, it doesn't even know that it can capture opposing pieces. And AlphaZero's training consists of playing itself multiple times and learning from each game and developing a style of chess to win. So how does AlphaZero work? AlphaZero is a deep neural network, which can be represented by the function on screen here. And the parameter, where it can be represented by f theta s with a parameter theta, where s represents the board position as input. The output p is a vector of move probabilities, and each move probability can be represented as a function seen here, where a is any given move in the position. It uses these move probabilities to obtain a value v, a scalar estimate of the outcome z from the position s. This can be represented as such, as seen in this equation. So basically, it obtains the probability that you would get a dominant position or even an improvement in the position from a move. and it uses these probabilities to try to evaluate which move it can play. So when it's trying to determine which moves it can play, there's a wide possibility of moves. And being a engine, it would look deeper than just one move. It would look 3, 4, 5, 6 moves into the future. And when you're doing that for 50, 60 moves, you get, or even further, if you go deeper into the position, you'll get a massive, a huge position that, it takes a while to determine which move out of all these possible moves and positions, which one would you prefer to go after. So to search for the ideal move, it uses a Monte Carlo tree search algorithm. And this search is guided by the move probabilities and the outcome estimates generated by the neural network. Each search consists of a series of simulated games of self-play. In each simulation, it selects a move A in each state S, which has a low visit count, which means it looks at moves that it has not played before, and it has a high probability and a high outcome estimate value from the neural network. So basically, when it's training, if it has played a move before and learned from it, it tries new moves to determine if it can find a better move, or if it's a worse move and they should put away like that idea to get to whatever positions can be obtained from playing a move like that. This search, it returns a vector pi, which represents a probability distribution over moves with respect to the visit count at the root state. Games are played by selecting a move obtained from the Monte Carlo tree search, such that the move at that time is approximately the best move pi at that timestamp. After each game, a result Z is assigned to the terminal position on the board ST, where Z is equal to -1 for a loss, Z is equal to 0 for a draw, and Z is equal to +1 for a win. The neural network parameters of theta are updated, attempting to minimize the error between the predicted outcome Vt and the game outcome Z, and to maximize the similarity of the policy vector Pt to the search probabilities pi-t. These parameters are adjusted over a gradient descent on a loss function L that adds the mean squared error and the cross entropy loss generated together. And it can be represented by the function below. So when these engines are running, you have to simulate the board. You have to set up the board in a way that the engines can quickly understand what's going on. And it's very efficient for each position to be shown to the engine and can generate moves quickly. So the way that they do that is by using an image stack of size n by n by mt plus l. To explain what that means, n by n represents the size of the board, 8 by 8. And it is and the concatenation of t sets of m planes of size n by n. Individual sets of planes represents the board position after each round of moves. So the mt plus mt represents the state of the board, and L represents the move that you can play. So this is how it sets up the moves that you can play and how it represents it. So the board is oriented such that it's the perspective of the player whose move it is. M, which represents the feature planes, consists of a binary feature plane, which has two sets of planes. One plane to represent the presence of the current player's pieces, a plane to indicate the type of pieces present, and a final plane to indicate the opponent's pieces. So M is basically vector, which represents the state of the board. L is a constant value plane. It represents the turn player's piece color, the total move count, and the state of certain special rules, if whether you can castle, whether you're repeating moves, or how many repetitions have occurred, and the number of moves made without progress. This means the number of moves played without capturing a piece. So if you don't know the rules of chess, if you repeat moves 3 times, like you play the same both players play the same 2 moves 3 times in a row, it's a draw by threefold repetition. And if you play 50 moves without capturing any pieces, it's an automatic draw. So now that the board has been represented and you see how the neural network functions, let's look at how the engine makes a move. So moves consist of 2 operations. You have to select a piece to move, and then you have to select a legal move for the piece. This is represented by an 8x8x73 plane, where each 8x8 plane represents the square that the piece is currently on. 56 of these planes represent a queen move. If you can move the piece, the queen moves, basically, if you imagine the 8 cardinal points, north, northeast, east, southeast, south, southwest, west, and northwest, it can move vertical in any direction, left or right in any direction, and it can move any direction on its direct diagonal. So 56 of these planes represents any queen moves it can make, and if that a subset of that is any moves a rook can make and any moves a bishop can make. So these 56 planes can represent those 2 pieces as well. 8 of these planes represent a move that the knight can make. Sorry for that typo. So the knight moves are different from how the queen moves. So you need 8 planes to represent the knight moves a piece can make. And the last 9 planes are unique in that they represent moves a pawn can make when it's on the 7th rank. So if the pawn moves from the 7th rank to the 8th rank, it can promote to a queen. And when it's on the 7th rank, it can move in 3 directions. It can capture to the left, on the diagonal to the left, capture on the diagonal to the right, or it can just move forward. And if it's under promoting, it can promote a piece, either a knight, a bishop, or a rook. And these are 3 pieces. So this indicates the 9 planes used to represent this under promotion. So when AlphaZero is training, the Monte Carlo tree search simulation is run 800 times, and the learning rate is initially set to 0.2, then altered to 0.02, 0.002, and 0.0002 over time as the learning rate needs to be lowered. Moves are then selected in proportion to the route visit count. So when it's training, it wants to see a wide variety of moves so it can learn about all sorts of different positions. Therefore, it attempts to play moves that have not been played often. Noise in the form of Dirichlet noise is added to the prior probabilities in the root node. So this noise is scaled because there would be illegal moves. There would be illegal moves, different types of illegal moves where a piece can't move past another piece. So if a piece is pinned, that's another way of playing an illegal move. So this noise is added. So to determine how strong AlphaZero is, it was compared to a baseline program, Stockfish 8. This is the program that it beat in 2017. And an ELO rating for both programs was determined. The probability that player A will defeat player B was estimated by a logistic function as represented here. And the ratings E dot were estimated using a Bayesian logistic regression using a standard constant C ELO is equal to 1 divided by 400. So when they were compared AlphaZero and Stockfish, a graph was made to compare its relative ELO compared to the amount of time it was allowed to make a move. So then as the amount of time it was given to make a move, you can see AlphaZero increased. It's a steeper increase for AlphaZero than it was for Stockfish, but as it has way less time to move, Stockfish is a better Stockfish is a better engine because it has databases of moves to play. So if it has a database of openings and end games, it doesn't need to learn a lot to play reasonable chess. So as my talk on AlphaZero is done, let me explain a bit about Stockfish. So the first version of Stockfish was developed in 2008. The version that was present in 2017 was Stockfish 8. And the latest version available now in 2021 is Stockfish 13. So it has evolved a lot over the years. It is used by the chess website lichess.org to evaluate games from its community. Lichess is a community-driven website. Everything on Lichess is free, lessons and everything. So it makes sense that it would use the engine that is available for that is open source. So Stockfish won, as before I said before, Stockfish won the top chess engine championship in 2016 and the 2017 chess engine championship, and it lost in 2017, which made it was a dramatic loss to AlphaZero. So Stockfish sets up the board very similar to AlphaZero, where it uses vector planes to represent every feature of the board and the position. The features used to represent the board or the position are chosen by strong chess players of the time, but they usually include the pawn structure, how strong or weak the pawn structure is, the safety of the king, whether it's in a bad position or in a good position, and the pieces remaining for either side. So these features are assigned a weight, and the position is evaluated by getting the sum of the features multiplied by the individual weights of each feature. This evaluation is then output in a human readable form with centipawns being used to assign a value to the position. So for example, if the evaluation of the position is +1, it means that white's position is equivalent to being up a pawn. But if, as you see, it's plus 0.01, it's equivalent to being up 1 centipawn. It's basically an equal position with a slight, maybe not even an advantage that a human can find. 0.0 means a dead equal position, and negative 0.2 means that you're up to 20 centipawns. Black is up 2 centipawns. So for each move, Stockfish creates a tree of possible moves and evaluates the positions obtained from each. It then sorts these moves into which ones obtain the best positions, which is very important for its search algorithm, as it's different from AlphaZero. So Stockfish generates a massive tree of possible moves up to a certain depth. And after it arrives at this depth, it searches through all these potential moves to choose the one that generates the best position. And even moves later on, it goes very deep into the position and evaluates lots of moves. It is assumed that each player will make the optimal move on their turn. Therefore, Stockfish attempts to look for moves that will leave the opponent with the worst choice of moves available to them. So if your opponent is choosing the best moves, you want to make a move where they basically have to choose, they have to choose the best of the worst in their case. So in this case, it uses a minimax algorithm to search for the best moves on the tree and utilizes an alpha beta pruning to reduce the search space of the minimax algorithm. Minimax search algorithm is widely used in game theory, especially in games like chess, where it's one player versus another, each have a turn to play a move. It's a depth-first search algorithm that iterates recursively through a tree of nodes. While it's iterating, it attempts to get the best possible position for the player. For one player, it maximizes their ability to win and attempts to get the worst possible position for the opponent or minimize their ability to win. Alpha beta pruning is the search algorithm that is used along with the minimax algorithm, and it eliminates nodes and all that node's children's nodes when that node's outcome is worse than a previous node. So while it's searching, it records the node with the best outcome and compares all other nodes to it, and then eliminates that node eliminates a node where it has a lesser outcome than the previous node analyzed. So if Stockfish is going through, hundreds of thousands of moves and it only has like 5-10 seconds to play, it needs to go through these moves relatively quickly and select, a good one. And the alpha beta pruning algorithm is really efficient at helping the minimax algorithm is very good at limiting the search space of the minimax algorithm and quickly identify an optimal move. So it also reduces the amount of resources used by the minimax search algorithm. It doesn't have to go through a lot of moves to get to an optimal move. So as mentioned before, Stockfish is one of the engines where a lot of strong chess players are allowed to contribute to how Stockfish is developed. So Stockfish uses a database of openings and endgames, and when it plays these openings and endgames, it just plays these openings straight from memory. No learning takes place. Only when only when a position gets really complicated, then it attempts to learn and evaluate the position. So the database of openings available to it would obviously contain the best responses, and it also contain whether or not the opening is strong or weak, or the best ways to play against the opening. And of course, Stockfish plays endgames straight from the database if it recognizes them. With this brute force way of generating and selecting moves, Stockfish iterates over millions of moves per game. Short games, 20 moves, it can iterate over millions of games to select a strong one. And Stockfish requires a lot of resources to be able to select an optimal move out of these millions of moves generated. So I spoke about AlphaZero and Stockfish. This picture is basically a summary of another match they had after the 2017 Chess Engine Championship. They basically the scientists decided to choose certain very popular openings, play the openings, and then allow the engines to play the position. And AlphaZero was proven to be much stronger than Stockfish, but certain openings that were seen as strong, AlphaZero disproved them, especially the French defense AlphaZero. You can see when AlphaZero played with the white pieces against the French defense, it didn't suffer any losses. It didn't suffer any losses with the white pieces, but with the black pieces, it suffered 4 losses with the French defense. So these are a few popular openings, and you can look at the stats available here. I know it's a bit small. That's why I tried to get the picture to fill the screen, so the statistics would be easier to see. move on because yeah, there's another list of defenses. So the best performing defense for black was the Sicilian defense because Alpha Zero struggled to win with the white pieces against it. If you can see here, it only won 17 times and drew 32 times against it. It wasn't dominant against the Sicilian defense with the white pieces. So after all of this information, the main differences between these engines are Stockfish has a database of openings and endgames, which is observed from which can be observed from you know humans have provided this database of openings and endgames, and AlphaZero has only learned from playing against itself. Stockfish lost to AlphaZero, and this may also be down to humans having a say in how Stockfish evaluates positions, whereas AlphaZero learns basically an artificial intelligence, and it shows that machines will be stronger than humans at chess, and Stockfish was limited by the information it learned from humans. Stockfish analyzes a wider range of moves when it plays a game, but AlphaZero analyzes positions it likes more deeply to generate moves. AlphaZero identifies a move very efficiently that it likes to play, simply because when it plays a move, it goes very deep into the position to generate stronger moves, deep into the future in the game. So, as said before, Stockfish has a human bias, and top players participate in its development, but the only improvements AlphaZero will get is via using better AI techniques. And Stockfish uses way more memory and resources than AlphaZero. AlphaZero analyzes positions more deeply. So the main difference between Stockfish and AlphaZero is Stockfish analyzes positions in a more human way. It analyzes lots of moves. But when AlphaZero finds one move, it goes deep into the position. It can analyze a lot of moves. So it can analyze from early in the middle game straight down into the end game. It can evaluate that, I can get a winning end game if I go into this line of moves. Whereas Stockfish is a more short-term planner when it's playing a chess game. One of the conclusions you can draw is that on a human level, Stockfish is much better than AlphaZero at analyzing chess positions. AlphaZero would play moves that a human just would not understand, but Stockfish would generate moves that a human would understand, and the best possible human moves in a position. This is why AlphaZero can't be used on chess websites to evaluate positions between humans, because it would not generate, when it generates a move, it will generate a move that human won't understand, and that's not good for like beginners. When beginners play, you need to be able to teach them how to play chess, and Stockfish, its way of evaluating a position is way better for that purpose. But AlphaZero has shown that an AI approach to chess will generate a playstyle which is far superior to any sort of chess that a human can play. Humans are way behind engines in that regard. And AlphaZero has altered the way chess is played at the grandmaster level. With certain openings, it has refuted certain openings, and it has a style of playing chess that grandmasters are learning from. I won't go deeper into that because that's not part of the AI, but the world chess champion Magnus Carlsen, he has analyzed games that AlphaZero has played with certain openings and against certain openings, and he has applied some of AlphaZero's play to his repertoire. And he has said that certain moves he doesn't fully understand, but he plays them because it generates a stronger position for him. And that's a route that competitive chess has gone down, where engines generate moves that humans can't understand. And humans play these moves because eventually, if they keep following the moves that an engine plays, if they prepare for a game using an engine, they can play moves at a very high level and they can win more games playing these lines. So the one of the important references I used, there was this paper on AlphaZero, which was very enlightening. That's this reference here. And this was done by a team at Cornell University. And this is another paper that I used to observe to see how stockfish is used. I think that's the end of my presentation. Any questions? Anyone?
Yeah, thanks, Kaveer. Very interesting. Yeah, you know, I really have no questions. The only thing was interesting is the fact that you said AlphaZero required less resources than Stockfish, right?
Yeah, because I think it had a way more efficient way of evaluating moves and generating moves that it wanted to play.
So when they set up these competitions, do they have limits on the different resources required, like computing, memory, and
Yeah,
storage, etc.? So they place limits.
they do place limits. I think, geez, I should have put this in the presentation. They used for stockfish, because AlphaZero was basically beating it all the time. For stockfish, they gave it a bigger GPU, and they gave it I think 1 terabyte of RAM or something. It was a huge RAM that they gave to stockfish. But even with the vast difference in resources, just the way AlphaZero learned how to play chess, just by playing itself, no human interference, it learned a much superior way of playing chess than stockfish. So even if they gave stockfish more resources, AlphaZero it just knew how to play chess better.
Okay, nice. Yeah, thanks.
I got a question. Do you think that, I don't know how to phrase it, do you think that maybe the chess rules should be updated? Because I really feel like it's somewhat against the faith of the game if it is, you don't really have a counter strategy to your opponent's strategy if there's no strategy involved. In case of AlphaZero, I just wondered, what are your thoughts on that?
Well, chess has many different time limits, right? So there's rapid, that's like 10 minutes for each side. Blitz is 3 minutes for each player, and they don't add any time for players. So you have to play the full game with only 3 minutes available. So I think in the shorter time formats, no, chess is perfect for the shorter time formats. For the longer formats, there's a tournament going on now in Romania, and for the first 3 days, there's 10 players, grandmasters in that tournament. For the first 3 days, well, they play. It's a round robin style tournament. It's a classical time format, so I think there's like 30 minutes for each side. There's been 13 draws out of 15 games. So the longer time formats, you're going to see a lot of draws, as defenses are improved. As attacking chess, you really just have to understand all the moves to play attacking chess. But defensive chess, you don't really need to understand the moves to play good defensive chess. But attacking chess, if you make one blunder, you're going to lose. So, for the longer time formats, they'll have to evaluate, what they can do to um, prevent people from using engine lines and engine moves all the time. I think one of the ways they can change the point system, because in these tournaments, when you win, you get 1 point, and if you draw, you get half a point, and if you lose, you get no points. I think if they increase that gap more, because if you see like a sport like football, there's 3 points for a win in the league format and 1 point for a draw. So there's more incentive to play really attacking and to go for a win. I think if in chess they implemented something like that, like they made a win more valuable than like 2 draws, I think it would change chess and players would play more aggressive, and they would play certain suboptimal, not engine lines simply to get the opposition player out of his preparation. And this is one of the ways like these top grandmasters win games. They play certain moves that have never been played before just to get the opposition player out of his comfort zone. So I think that is the way chess has to go in the longer formats to ensure that engines don't take over, and there's not a lot of draws here. I hope that answered your question.
Yeah, I have another question. And when you said that, sorry, what's the name of the other one that's not the Google one?
Or stockfish.
Yeah, so the stockfish is good for teaching people because that's because and when you say that the other one, AlphaGo,
AlphaZero.
makes moves that people don't understand, that means that if it's giving you some guidance, the strategy that's employing isn't obvious, right? That's what it means.
It it means that it sees deeper into a position. Like chess, the top chess players, they can see 4 or 5 moves into the
Yeah.
position if like optimal moves are played, right? I think AlphaZero with the neural network approach, it might be able to see maybe 10 moves later, 20 moves later. And Stockfish doesn't use this neural network approach. So if they played against each other and AlphaZero can see further into the position, there are some moves that Stockfish will miss. And obviously those are
Mhm.
moves humans would miss as well. So I think Stockfish should beat
Oh,
all human players in a human style, but AlphaZero plays in a completely different way.
all right. Okay,
Yeah.
understood. Thanks.
Any other questions?
Do you think there will be?
Well, if
Oh, okay.
Yeah.
So
Yeah, you can talk.
you may have covered this, and I came in late, so I apologize. Kaveer. Do you think that there will? What do you think Stockfish would need to be able to do to start to beat AlphaZero, especially as it comes in to there's certain things that it could be better at.
I think it would have to implement certain new AI techniques. It has to be doing something different from what it's doing currently, and then it will have to be doing something different to what AlphaZero is doing. So new AI techniques that can like go deeper into positions. If people discover new techniques in game theory and all of that, that's the way that that's the only way you can catch up to AlphaZero.
Okay. And so I know we're rule bound right now within chess, but let's just and this goes way beyond the scope of your talk. But did you see any places where Stockfish actually beats AlphaZero? You may have covered this, and I apologize, but like is consistently better outside of chess?
Well, these two engines were Stockfish was specifically created for chess. AlphaZero, well, Google developed AlphaZero to play 3 games,
Yeah.
and they just modified the engine for each game. They created a general algorithm to play shogi. That's basically a more advanced version of chess in Japan. a game called Go, and it also to play chess. So it implemented these approaches for those 3 games.
I see it. No one's taking Stockfish and say, well, you know what? Maybe you're better at this game. Like, we'll put you on like StarCraft or something.
No one has done that. I think Stockfish, because it's an open source and it's a community-driven engine, it's basically being kept up by chess lovers because it was created for chess. So I think that's why they wouldn't use Stockfish in other games.
All right, no, that's cool.
Certain engines and other games would probably use similar approaches to what Stockfish uses, but not specifically Stockfish.
Thanks, man.
Hey, just sorry, my internet kind of dropped there for a bit. I'm not sure if I missed it, but did you cover the evaluation techniques or the differences between AlphaZero and Stockfish?
Oh, that's another thing I should have put in my presentation. So no, I think I put it. Stockfish, when it's evaluating a position, it analyzes, like I said, it analyzes pawn structure, it analyzes the safety of the king, and then it analyzes like how many pieces are remaining on the board for each side. And then it uses these features with an individual weighting for each feature. And then it finds the sum of the feature multiplied by the weighting, the sum of all those values. And with that value, it evaluates who has an advantage. So it evaluates advantage by using centipawns. So let's say it evaluates a position and says +1. Plus means that it's white who has the advantage, and that 1 means it's a whole pawn up. Well, the whole position has been evaluated, and white is the equivalent of being a pawn up. And if the evaluation is like -0.5, it means that the black pieces, if it's a negative, they are up 50 centipawns. So it evaluates positions like that. And I didn't say, but Stockfish, if it realizes a position where either side has more than +10 advantage, +10 pawns advantage, it instantly resigns. AlphaZero, they didn't say how AlphaZero evaluates positions. Again, I think that's down to it evaluating positions way different than how a human would. So it's very difficult to represent that evaluation in a human form.
Okay, that's interesting. I was probably thinking, I was watching a few YouTube videos in the past when AlphaZero was playing Stockfish. Matthew
Knew
Sadler.
someone here would like chess.
Yeah. So Matthew Sadler, UK Grandmaster, was basically analyzing a bunch of the positions with his co-host. He wrote this book called Game Changer, and he makes the argument that AlphaZero was actually closer to human-like in its evaluation of positions, and he pointed towards I think it was game 12, if I'm not mistaken, and the title of that video is Long-Term Sacrifice. So AlphaZero in that position was able to evaluate almost 15 moves out, that even though it was 3 pawns equivalent down, which is how I guess Stockfish would have viewed it, that it still had the better position because there was nothing that Stockfish could do to prevent its plan. So I was curious as to how like AlphaZero was able to do that, and if in the course of coming across this, the evaluation technique was
I think that evaluation is a qualitative evaluation. Like the English grandmaster you mentioned, I think he watched the position and his style of play AlphaZero had, and he determined well from his experience that it evaluated that it the game would get to this position from how many moves ago when it sacrificed a piece or 3 pawns. I know you said Alpha Zero is
But
up 3 pawns in that
oh,
position.
yeah. So,
And
that was Alpha Zero's evaluation.
yeah, so I think Alpha Zero is, as I said, Alpha Zero is better at long-term planning than Stockfish. Now, obviously, Stockfish would be better than humans, but Alpha Zero, I think mainly because of the difference in its approach to training and the fact that it has no human interference in its training. I think that is important, that it's a machine, it's going to learn more about chess than a human would, especially with the amount of resources available. And that is the style of play the machine came up with. That would be the best way to play chess.
Yeah, it's worth checking out so some of those videos on Chess 24, because like in the championships between Magnus and Caruana, they utilize Alpha Zero to evaluate the position, and almost 96% of the moves that Magnus made is what Alpha Zero said should have been made. And that's without...
Magnus is known. He has studied from Alpha Zero's games.
But this was before Alpha Zero became available to Magnus.
Oh, wow.
This was the Magnus Caruana back in
2016.
Well, yeah, more or less.
Yeah.
The major championship there. So it was interesting that Alpha Zero, without seeing Magnus, was already on par with,
Magnus
with
is a really good chess player.
Well, Magnus is practically a machine. I mean, he's probably the best we'll see for a while. But yeah, it's worth seeing. But the evaluation technique of Alpha Zero, I think, is quite interesting if someone is able to understand it.
Yeah, but I think you'd have to wait for a few more developments, and I think maybe human grandmasters might have to get stronger before we could get increased knowledge on like how Alpha Zero sees games, because the scientists, they won't be able to see it because they won't be elite chess players. They won't be able to understand everything that why the engine is doing this. So, what have you. Only a really elite chess player would be able to understand it. So maybe grandmasters have to become stronger for that to happen.
Maybe, yeah. In most of the games that you see Alpha Zero play Stockfish, Alpha Zero doesn't play computer moves, which is weird, or what is quote unquote computer moves. It's almost like it read a book that humans would have written, like exploiting weaknesses, the principle of attacking in the center, controlling the center, all of that it learned on its own. It learned how to control the center on its own, which is, fun.
It shows that certain human principles are good in chess, and I think you can say it's not computer moves, but remember, the computer moves that we are accustomed to are moves that, Stockfish was the main engine for most of this the last decade. So those are the computer moves we'd be accustomed to. So if it plays something other than that, well, obviously we would be amazed.
So Stockfish, Stockfish plays moves like when it's playing black in the French defense or something like that, Stockfish would play bishop a6, which is something you never really see Alpha Zero do, because it knows how valuable the light square bishop is for black. Yeah.
I know one of the games you're talking about where that light square bishop went to that square and then it got locked out. It used Alpha Zero used pawns to lock it out.
Yeah.
Of the game. Yeah.
But of course, Stockfish thought that was a good move.
Yeah.
So I guess this comes into like something with like the bias in AI that we inherently program. Instead of finding the best possible solution, we program in our own preconceived notion of what could be a good move, and then learn far later that maybe, when we have an alternative, like, wow, why were we doing that in the first place?
I think maybe not programming, but if there's any data available on chess, humans have collected it. And if it's like data on human games, well, it's a human playing, it's already tainted by
Yeah.
humans, it's already, but the bias is already there.
Yeah.
So yeah, and I think Stockfish has a lot of contributions from like top chess players, so that's where it would get the bias from.
So I wonder if there's a way that a merge could happen. Like I know AlphaGo has. Let me not theorize. It's late for y'all.
And remember as well that in some of these games they told AlphaZero and Stockfish to play a certain amount of moves from standard openings and then take over from there. So it was interesting that AlphaZero is able to understand how to evaluate a position not from the beginning.
Yeah, I think that was outside the 2017 match I spoke about. I think they were just allowed to play their own game in that match. But outside of that, when I showed the graphics, AlphaZero disproved a lot of popular openings. The French defense, it disproved the well, it wasn't present there, but the Queen's Indian defense, like the Queen's Indian defense isn't played at all at the highest level again because AlphaZero showed how to destroy it. So yeah, AlphaZero, it has revolutionized chess and changed it a lot.
For sure.